Good afternoon, everybody. We're at the AWS Summit Chicago. Welcome, thank you for coming. You all have storage. You all have storage on premises today, and you're all at an AWS Summit, so you clearly want to move to the cloud. In this session, we're going to cover Storage Gateway, one of our services that lets you move storage into the cloud while keeping workloads on premises. My name is Paul Reed. I'm a product manager in our Boston office. I'm going to be joined on stage by one of our customers, Dave, from Direct Supply, and a colleague of mine from the Boston office, Smitha, who's going to do a demo. So we'll try and keep this moving. So why are you here? You've got data, as I mentioned, and you want to move it to the cloud. So we're going to talk about how you can move that data. Maybe it's part of an application that you have today that lives on premises. You can't move the application. It's just not feasible to re-platform it. But you want to move the storage into the cloud as the beginnings of moving to an all-in cloud strategy. Or maybe you want to use that data downstream in the cloud with many of the services that are available to process that data in the cloud as you start to build up new workloads and new uses for that data. Maybe you want to use cloud storage just for backup, disaster recovery. We see an increasing number of customers that are using one of the AWS regions as their second data center for disaster recovery. So your disaster recovery involves moving data and applications. Obviously, the data needs to move continuously in order to provide you that recovery point objective, that recovery time objective that you need. Or maybe you're an all-in customer and you want to just migrate. You're doing a lift and shift. You want to close down your data centers. You want to move a filer maybe that's on premises into AWS. You want to do this for a lot of reasons, right? You want to retire a data center, as I mentioned. Management of all of this on-premises infrastructure is burdensome. You have a staff that take care of it. I love this picture because it's just wires, right? Everybody's seen this if you've been on a raised floor. And it costs. It costs you to run all of this stuff. And for those that have looked at the AWS Cloud Economics models, it's cheaper, it's more economical. We like to say, get out of the undifferentiated heavy lifting, let us take care of that, and you focus on your business. From a storage standpoint, in AWS, if you look in the middle here, we have three core storage services, or three core storage types, rather. File storage, object storage, and block storage. I'll start with object storage, S3 and Glacier. S3 created this object storage space. I'm assuming most of you are well aware of it, so I won't belabor what block storage and S3 can provide for you. Or what object storage, rather, can provide for you. EBS provides you block storage within the AWS platform, within EC2. And the latest addition to this core storage portfolio, EFS, providing you file storage in the cloud. On the left-hand side, we look at our data transfer services. We're going to talk about Storage Gateway, the one at the top of that stack there. We have other storage services, other transfer services that allow you to get data in. And again, why would you want to bring that data in? Well, not only are you putting that data in the cloud, where it's offsite at a lower price point than you could store on premises, but there's a whole series of services that you can now use once that data comes into the cloud. From something like a recent introduction of Macie to allow you to do data analysis, data tagging for security purposes, things like KMS at the bottom there to allow you to encrypt that data, to keep it secure, to make sure that it's safe. So how can you get that data in? Again, this session is about hybrid storage. So in this instance, we're going to talk about gateways. So here's a gateway that many people are familiar with, St. Louis Arch, gateway to the west. We're not going to talk about the St. Louis Arch, though it's a kind of a nice picture. We're going to talk about Storage Gateway. So in this instance, you have data that lives on-prem, applications that live on premises, data generators that live on premises, and users that are on premises that want to access storage. How does the gateway help them access that storage in the cloud? For many of our customers, their first use for Storage Gateway is for backup, disaster recovery, and archive. It's a very easy entry point to the cloud. You get used to the operating model, the economics, move your backups to the cloud, tell your boss that you're storing things in the cloud. It's a good tick box for those that are a little bit cloud shy, maybe, or an organization that's cloud shy, but you want to be cloud forward. What we're seeing with the service that we launched in 2012, so it's been around a while, is that customers are adopting it for a much broader set of workloads. And the reason for that being that when Storage Gateway brings data into the cloud, we bring it in its native format. We put it directly into those core storage services. So you can use that storage against anything that works against those core storage services. Again, whether it be first-party services from AWS, first-party capabilities from AWS, or many of our partners that sit down on the expo floor that have direct integrations to some of those cloud-native storage services in order to provide their value-added platforms. Storage Gateway is a service that deploys, it has kind of two core components. There's a gateway that deploys on premises, and there's a service backend that lives in AWS. The gateway that lives on premises is currently available as a VM for VMware or Hyper-V that you deploy into your data center. We also have an AMI for running it in EC2 if you choose to do that. Your applications connect to that gateway using standard storage protocols. We'll talk about that in a moment. Super important, your applications don't need to be modified. They see what they think of as on-premises storage, and the gateway surfaces that to them in ways that they can already integrate with. The gateway talks outbound to the AWS endpoints using HTTPS, so you can route it to a firewall, a proxy, or a SOC server. So it's encrypted on the way, outbound. You don't need to open up your firewalls to let traffic in. And that AWS service on the back end durably stores your data into S3, EBS snaps, or Glacier. The gateway really is just the entry point to the service. It's not really storing any data. It's kind of ephemeral from that standpoint. As an AWS service, we're integrated with a lot of the maintenance, monitoring, and management tooling that AWS has. So you get consistent experience across all of your AWS services. You can use the same KMS keys you're potentially using elsewhere, same access and identity and access management, things like CloudTrail, CloudWatch, all the services that other AWS services integrate with, Storage Gateway also integrates with to provide you that sort of single pane of glass from a management standpoint. We provide 3 types of storage. This is kind of important because there are multiple types of storage out there. We covered that when we talked about the 3 core storage services that AWS has in the cloud. We provide you file storage through our file gateway. So this gives you an NFS or an SMB mount on top of an S3 bucket. We provide volume gateway, which gives you block storage, volumes that surface to your on-premises applications through iSCSI, but the data is all stored in the cloud. You can access it as snapshots, CBS snapshots. And tape gateway, which provides you more than just tape storage, it provides you device emulation as well. And this is important because most applications that want tape storage think of interacting with a library. They don't think of interacting directly with tapes. They have a media changer and drives, and they want to shuffle tapes around this library and read them and write them and fast forward them and all this. So we provide that device emulation in addition to the back-end storage of tapes. So it becomes a really easy drop-in replacement for tape infrastructure. No matter what type of storage or type of gateway, if you like, that you're using, there's sort of 4 key features to the service. One, I mentioned it, it's the idea of standard storage protocols. You don't have to change your applications to store data in the cloud. If you have a file-based application, he does an NFS mount to the gateway, and he reads and writes files. Similarly with SMB, Windows-based SMB application, he connects to a file share, and he reads and writes files. The gateway provides a fully managed cache, and this is really important for applications that can't tolerate longer latencies of fetching data from the cloud. This instance, the gateway manages that cache of hot data locally on that VM using the storage that you assign to the VM. You don't have to manage that yourself. We manage the working set of data in there based on what your applications are doing. As you write data, again, the gateway is, we think of the gateway as ephemeral. As you write data to the gateway, we upload that data into the cloud. And we'll show how that works in a moment in a little bit more detail. We try and minimize the amount of data that we move between the gateway and AWS. We recognize that some customers don't have big network pipes, or they're sharing network pipes with other applications. So we try and minimize the data. We do compression, byte level puts, byte level gets. And at the end of the day, all of your data is stored in the cloud. We store it back in those core services, durable long-term storage in the cloud, accessible to you directly in the cloud. Let's go quickly through all 3 gateway types. I'll start with file, and then actually I'll hand it over, and we'll look at some of the use cases that one of our customers are using file for. So in this instance, I mentioned we provide NFS and SMB mounts. SMB was launched just recently at our Public Sector Summit in DC. NFS was launched back in 2016 at reInvent. So your applications see an NFS mount point, and they put objects into your S3 bucket. So one-to-one mapping between the files that your file-based applications see and the objects in your S3 bucket. We like to restrict access on the file side by IP if you're using NFS, or by Active Directory membership if you're using SMB, so the gateway becomes part of your AD domain. Once a user has access to the file share or the NFS mount, POSIX permissions apply below that. So again, what a file-based application would expect in terms of access control. We have a whole bunch of other options that you can apply on the file side, things like read-write and some other options that allow you to control and manage how file-based applications see this file system. On the S3 side, similarly, we have a number of options for how your data arrives, or how your data lands in S3. You can choose the storage class that it goes in. You can encrypt with KMS. You can do things like guess MIME type. A number of the core S3 features that you would have if you're using the CLI, the gateway supports and will perform on your behalf for file-based operations. What's really important here is the thing on the top. These are objects landing in your bucket, but you don't have to open your bucket up to a service accessing it. You give us an IAM role, and you give us the ability to assume that role, so you control access to your data at all times. Let's look in a little bit more detail about how some of these benefits, some of these key features work. So I mentioned the cache. Cache is really important for applications that can't tolerate the longer latencies of fetching data from AWS. So in this instance, we fully manage the cache. Some of your data is always going to live on the gateway in the storage that you assign to that VM. All of your data is going to be stored off in your S3 bucket. There's no limit on the size of the bucket. You can have petabytes of data in that bucket, and the gateway will give you access to it through maybe a couple of 100 gigabytes of local storage. We cache at a sub-file level, so this allows you to manipulate and access files that are even potentially larger than the cache. A nice parlor trick that I play is to edit a 1 terabyte video file with 150 gigabytes of local storage. And the gateway will allow you to do that because we're not talking about full file caching, we're not talking about full file transfer here. Data stays in the cache as long as we need it. We're not going to purge data from the cache just because we've stored it up in the cloud. Again, you've assigned storage to the gateway. We want to use it as efficiently as possible. So we're going to keep that storage as full as we can, representing the hottest data that you have, the most actively or most recently accessed data. How do reads work? Again, let's look at how the cache really functions under the covers. If I read data, I'm always going to read it from the cache. It gives me the lowest latency, so why would I go to the cloud? I'm going to read that data from the cache. Now, if the data is not in the cache, we're going to go fetch it from S3, just the pieces you want, put it into the cache, and then serve it to your application. We have a set of CloudWatch metrics that allow you to look at the performance of cache hits, or cache misses, to allow you to tune that cache size to include your working set of data. If your cache is too small, you'll get a lot of cache misses, so if you increase the size of the cache, more of the data will be read from the cache. We have a bunch of heuristics in the gateway as well, so if we see workloads that are common, something like a sequential read, we'll potentially prefetch data for you. We know your application is, say, streaming a video, so we see that, we recognize it, we prefetch data into the cache in order that you don't have buffering, you're not suffering that latency of demand caching every time. How do writes work? Similarly, we write to the cache. It's a write-back cache. We write to the cache, your application gets acknowledged that we've got the data, your application moves on. We asynchronously then upload that data to S3. We break the data apart, we do parallel multipart. We try and, again, efficiently move that data to S3. The durable storage is in S3, so we want to get it there as quickly as we can. So if my data is being asynchronously uploaded, how do I know it's gotten to S3? So in this instance, we have an API that you can call to say, tell me when my data is uploaded. I have a workload that's depending on it in the cloud. Call the API. After the gateway is completed writing the data up into S3, we send you a CloudWatch event. What does this allow me to do? This allows me to then trigger upstream workloads that are dependent upon that data landing in S3. So the data was generated by a file-based application on premises, and I can automate an object-based workload in the cloud accessing and using that data. The other part of our cache is a metadata cache. So one of the problems with caching this data is, well, how do I make file system operations efficient as I'm wandering around the file system? So we keep a metadata cache that potentially knows about many, many more files than we have in the data cache. So in this instance, if we're performing an LS or a DIR, I'm going to get that data from the metadata cache. Similarly, we manage that cache for you. We manage the parts of the file system that you know about. Millions of files can be known about by the gateway, but you can still have billions in your bucket, billions of objects in your bucket. And we're just going to fetch that data as we need it, cache it, serve it up to your applications. So what happens if I put an object into my S3 bucket and the cache doesn't know about it? Well, we have another API for that. You can call refresh cache. where the gateway will go and refresh the data that it has in the cache by performing list operations to look at the bucket to make sure that it knows about all of the objects in the S3 bucket. We're not walking the whole bucket, we're just refreshing the stuff the gateway knows about to keep the gateway in sync with what's in your S3 bucket. And we see this a lot in workloads that then want to bring data back from S3 back to their file-based users. For example, maybe you have a physical wet lab piece of equipment that's writing a file up to S3, you run an EMR workload on it, you produce some result set, your principal investigator sat in your site wants to look at that result set as a file. Mounts the NFS share, and he looks at the gateway, refresh cache takes care of getting that result set back to him. I'm going to hand over to Dave, who's going to talk about what they're doing with Storage Gateway. You've heard me for 14 minutes, but it's much better to hear from somebody that's actually using it as opposed to the person who's building it.
Sure. All right, thank you very much. Good afternoon, everybody. My name is Dave Stoffaker, and I am a principal platform engineer with Direct Supply in Milwaukee, Wisconsin. Today I'm going to talk you through how we are using File Gateway as a target for SQL Server backups. Now, Direct Supply is a company that serves the long-term care industry. So think nursing homes, everything from assisted living up to the most intense acute care, everything in between. And we serve that industry in three ways that we refer to as build, equip, and run. So our build story is that we have an interior design, architecture, and construction organization that can handle projects of any scale, from a cosmetic facelift to the complete design and delivery of a fully outfitted nursing facility. Our equip story is really the roots of our business. We were founded as a maintenance equipment company and quickly expanded into medical products and durable goods for the long-term care industry. Today, we publish a 2,000-page catalog every year and operate a large e-commerce portal that long-term care industry facilities can use to purchase all the products they need to equip and serve their patients. Now, there's two pieces to our run story. The first is an equipment lifecycle group that we refer to as TELS. They provide services and support around the equipment that we sell, and we can also help facilities locate ancillary services like electricians, plumbers, gardeners, things like that. So they are a service organization serving the long-term care industry. We also operate a large purchase and procurement portal that we refer to as DSSI. So we connect facilities or corporations of facilities with all of their preferred vendors on the back end and layer our own homegrown tool set on top of that purchasing process so that they can understand and better track and manage their spend and forecast upcoming needs. Now, we were founded about 34 years ago, and very early on in our company's history, we founded our first IT department. And the goal of that department was to develop solutions using technology that gave us an advantage in serving our customers. So we were doing things very early on in our history, like customer relationship management software, before you could just go out to Salesforce and set that up yourself. We were doing data analytics and data reporting before those were off-the-shelf products. We were very early adopters of e-commerce practices and selling over the web. All of this has been homegrown in a largely Windows environment. Now today, our physical infrastructure in our own data center is about 800 VMs, 100 physical servers supporting those VMs, and all of our data, including backups and DR copies, takes up about 1.2 petabytes of storage. Now, just for context, we put our first storage array into our data center in 2003. It was a whopping 4 terabytes, and we were only about 30% occupied when we put it in. So our data has exploded over the last decade and a half and continues to grow. Now, all of this IT, all of this software, all of this infrastructure supports our 1,200 partners, about 300 of which work remotely through a VDI environment that we also maintain and support. And together, they serve our thousands of customers every day. Now, a few years ago, we had a very familiar story that probably most of you have gone through. We had a lot of infrastructure that was coming up for end of life and life cycle, or end of support, start of extended support. And that's a very high dollar amount position to be in. We also were running everything on Windows, and we wanted to introduce more open source into our environment where it made sense to. And we wanted to start automating more of our processes and adopt more DevOps-like behaviors in our environment. So we decided to use some open source software, and we built our own private cloud running on essentially an open source hypervisor with a very large amount of customization on top of it, running on commodity hardware. Now, our goal as a business is to improve the lives of America's seniors by making it easier for their health care to be provided for. Managing that infrastructure was not in our core competencies. There's a lot of work that goes into maintaining an off-the-shelf infrastructure, let alone an infrastructure that we've grown ourselves. So we made the decision to pivot away from our private cloud project, and we partnered up with Relic Cloud to figure out how do we move our on-campus workloads out to AWS. So they came in and they helped us train up our first 5 engineers on our cloud team, and we set about the business of figuring out our environment and our infrastructure so that we could plan out our move to AWS. We started with our landing zone, things like our VPCs and subnets, setting up some of our basic security policies. And then we as a cloud team figured out our standards for how we're going to operate in the cloud. And this is important. So we adopted things like everything that makes sense to automate should be automated. Everything should be stored as infrastructure as code. So we wanted to be able to change track every single thing that we turned on or off, changed in our environment. We wanted to have that tracked as code. Third on that list was we wanted to make our design agile so that we could adopt new technologies and new features as they became available, and we didn't commit ourselves to a very hardline specific architecture that can't evolve with the cloud. And then last on that list, we wanted to make repeatable patterns so that the right way to do something is the easiest way to do something. So we spent a lot of time developing a service catalog and various automations that other teams can consume to reproduce reliable infrastructure patterns very easily. Now, all of that in play allowed us to grow our team from 5 members to 25 members at the beginning of this year. So we brought in 20 new partners. When I say partners, I mean employees. So we brought in 20 new employees onto our cloud team, got them very quickly trained up, and our first migration was our SQL reporting environment. So there's several terabytes of data running in Microsoft SQL that we were going to build in EC2. And we needed to get all of our partners working together to make that migration a success. Now, the nice thing about our SQL reporting environment is that while it is business critical, the blast radius is relatively small. So if anything were to go bump in the night, it doesn't affect our customers being able to get their products and goods delivered. It just means that we have to get it fixed very quickly. Now that that's done, we are shifting gears into looking at our e-commerce environment, which is going to be an even bigger migration for us. So with that background, one of the things that we had to solve for in our migration to the cloud was how we're going to protect SQL. So on campus, we have SQL doing a log backup every 15 minutes to a NAS environment. Every night, it does a differential or a full backup to that same NAS environment, and then our backup software comes along, picks up that data, and writes it out to a data domain, a purpose-built disk-based backup appliance. Now, both the NAS and the data domain are replicated to our DR site. So if we had a failure, we've got all the equipment and all of the data that we need to be able to recover to within 15 minutes of the crash and have that system online within about 2 hours. Well, we didn't want to have all that infrastructure out in the cloud, so we knew we had to think differently about how we're going to approach backups in the cloud. So the first piece of our story here is that you've probably heard the cattle versus pets conversation in regards to cloud architecture. The real high level on that is that pets are things you invite into your home and you take care of. You love them, they've got a bed in front of the fireplace, you've given them a name. They're very special and you're going to do everything you can to keep your pet happy and healthy. Cattle, on the other hand, roam in herds, and if one of them tips over, you just go to the auction and bring a new one back and introduce it to the herd. So we wanted to operate in a way that we identified our data as the pets. Our SQL data is the special sauce. The compute and the SQL instance running in front of it, if we're doing that as infrastructure as code, then rather than firefight and troubleshoot why an instance might not be behaving properly, we can just relaunch the instance from scratch and get a brand new fresh instance automatically. So by doing that, it allowed us to rethink the role of deduplication in our environment. We back up 800 copies of C:\Windows every single night. And our data domain does a great job of deduping all of that data so that we're really only storing one copy of that Windows directory. In the cloud, our switch to managing our actual compute nodes as cattle allowed us to eliminate needing to build a dedupe solution in AWS. Again, we're protecting the data. The operating systems are disposable and reproducible. So the third thing we wanted to do is accelerate our backup and restore. The data that we were storing on the data domains required a backup team member to restore the data back to the NAS device before our DBEs could start fixing whatever was wrong with our SQL data. We wanted to move all of that backup data closer to the application so that the DBEs could work effectively without having to involve other teams and create other escalations. The fourth thing is we wanted to make sure we maintained application consistency with our backups. So you might be thinking, well, why don't you just use snapshots of your volumes? Well, that's great, but we need to snapshot several data and log volumes consistently, and we didn't want to lose any data that was in flight. So letting SQL write its backups out in a crash-consistent manner was a much better approach for us. All right, so when we got into AWS, our desired state, like I said, we wanted to eliminate the backup application from the data flow altogether. So no more Commvault, no more data domain. We wanted to still be able to produce a log backup every 15 minutes and be able to recover a SQL environment within about 2 hours. And then we wanted to make sure that, because now we're able to replicate to a secondary physical data center, that we had some means of replicating that data to another location. In our case, that was a separate region, and we're actually working on building a separate account that will replicate that data into. So if anything happens to our primary account, we have a completely separate account with all of our data in it that we can use to recover the business. So File Gateway became kind of the cornerstone of our architecture here in the cloud. So within our File Gateway, each SQL instance has its own prefix, or in the prefix in the bucket or file path through the gateway. When that SQL server starts up, it runs a mount command that attaches it directly to its path in that gateway. All of its backups are stored in that path. So on every single SQL server that we're running, it appears as a local mapped drive for all of their backups. Now again, this is the same file gateway architecture slide that we saw earlier. The gateway has a cache volume, so when we write our backups, they're writing to that cache volume, and then the gateway is copying that data to S3. The most recent and relevant data is remaining in that cache until we need to free up space in the cache. So if we have to do a restore right after a log backup, well, it's going to be pulling that right from the cache. Now, like I said, one of our early cloud principles that we adopted was we wanted to automate everything. And at the time we were doing this a few months ago, there was no CloudFormation or Terraform that would allow us to automate the gateway. So we kind of reverse engineered the process that goes on when you launch this from the console. And we have a simple bash script that uses Terraform to stand up the infrastructure. So if you're not familiar with Terraform, it's an infrastructure as code language that you can use to deploy your infrastructure. So that stands up an EC2 instance running the storage gateway AMI. It configures and creates the EBS cache volume, the security group with the correct ports open so we can communicate to the gateway over NFS. It creates our Amazon S3 bucket, and it creates the IAM policy that allows our gateway to manage contents within that bucket. When all of that is stood up, our script makes sure that the resources are online, and then it goes through the same process that you would go through in the console to activate the gateway, configure the cache volume, create the share, and then our last step is that we tag all of these resources so that if we need to assemble the mount path and mount string as code, we can pull all of the necessary components right from the tags on the gateway. All right, so outcomes of this architecture, we were able to maintain our 15-minute recovery point objective because we left SQL scheduling those backups every 15 minutes. The recovery time objective of 2 hours is still in play, but the great thing is that we have eliminated Commvault from the entire process So that RTO goal hits for any restore that we would do going back through our entire backup archive, not just the backup we produced last night. A few enhancements. We want to boost the I/O capabilities of our cache volume. So we're going to go from GP2 to an I/O optimized volume on that. And we're likely going to increase the size of our gateway EC2 instance from an M4 extra large to a larger instance. Right now, we've got several SQL instances backing up to this, and we want to keep one single namespace in the environment. So rather than having additional gateways out there, we want to just grow the size and scale up a bit. The last thing we're going to do is we run all of our jobs at the same time every morning, and it creates a very spiky workload, and we'd rather be a little more consistent and intentional about how those jobs run against one another. So we'll probably be taking on some scheduling work as well. Now, our relationship with Gateway doesn't stop there. We've also launched a file gateway with SMB and are in the process of migrating a 30 terabyte video archive out to that gateway. So we film every major campus event, all of our company picnics, all of our, if we have guest lectures come in, all of our quarterly shareholder meetings, all of that video footage is the filmed history of our company, and we don't want to give that up. So the archive is a perfect use. We have 10 people that need to modify the archive in a single Active Directory group, and we have it readable to the entire company. So the security model fits exactly with the POSIX-based permissions that the SMB stack in the file gateway is going to give us. So we're in the process. User acceptance testing has gone fantastic, and we're in the process of figuring out the next steps to get that data all the way out into a file gateway. After that, like I mentioned, we produce a 2,000-page catalog every year, and that takes a lot of photographs and a lot of creative content. And we have that content also living on premises in a large NAS environment. So there are some tighter integrations between that data and some other third-party products that help populate some of our website content. So we're working on those integrations, and we'll likely be moving that data out next to get that off of our NAS filer as well. And then after that, we have a large corporate file server that we need to redesign, and it holds all of our user-generated content. So we're looking at ways that we can break that up and prepare that to move out to AWS as well. All right, Smitha.
Thanks, Dave. Hello, everybody. I'm Smita Shriram. I'm a product manager on the storage gateway team. So today I'd like to do a demo of a common use case that Dave just spoke about that they're using in their environment, which is using the file gateway to store and access your SQL database backups in S3. If you see this diagram looks a little familiar to what my colleague Paul Reed showed you a little earlier. So I'll walk through this architecture, and then I'll do a quick demo on how you can set this up in your environment. So if you see here, in your data center, you have your storage gateway VM running, right? Within the VM, you've got your local cache that we talked about a little earlier that stores a copy of your most recent data. And then you have your domain controller, which is your Active Directory domain. The gateway joins your Active Directory, becomes a member of your Active Directory domain, so that any file share that exported through the gateway will be accessible to AD authenticated users. And then the most important part is your SQL Server application, right? That's producing these backup data. And then with SQL Server, you also have SQL Server Agent, right? And that's probably what you'll use to schedule these nightly backups. And then I'll show you how you can tie that in with a file share exported to the gateway to store those backups. On the AWS side, we have your S3 bucket, right? That's where all these backup SQL backups go into, right? Because now that data is in your S3 bucket, we can see what are the options that you have within AWS. An example is life cycling into Amazon S3 infrequent access. You can set it up after 7 days. It goes into infrequent access. Another option is life cycle into Amazon Glacier, after 30 days, or even expire or delete the backup after a certain number of years. So what you can do is you might have certain compliance retention requirements, and this will allow you to meet that. So with that, and then there are other things that you can do once the data is in Amazon S3, right? One of the examples is you can automate in-cloud restores, right? Or you can even, if you remember, Paul Reed showed you a slide on requesting a CloudWatch event once the data is in S3. So you can do several automations there. One of them is getting notified, hey, that data is durably stored now in our Amazon S3. All right, so with that, I'll move to showing you the setup that I have currently. If you see in the Storage Gateway console, I have my gateway right here. Oh, as you can see, I have an update that I'm notified that there's an update available, right? I can either take the update right away, or it'll get automatically applied to my gateway during the maintenance window. I also have my file share. And this is the file share that I've exported using SMB, right? And you saw those mount options that Dave pointed to in his slide earlier. Those are the similar mount options that I've used to mount the file share. And this file share is backed by my S3 bucket that I'll show you in a second here. So you can see in the S3 console, this is my S3 bucket where my backup's going to. And I have a backup file right there that's being lifecycled to standard IA. So moving to the Windows side of things, this might be a familiar application for a lot of you, Microsoft SQL Server, right? And here I have a database that's called AdventureWorks, right, that I'm using for this demo for backing up. Within SQL Server Agent, now I'll show you the job that I'm going to run. And before I run it, I'd like to show you what's in there and the significance of it. So if you see, I have a script written here that says, let the backup jobs go into the file share, right? And the file share is nothing but the IP address of my gateway and my Amazon S3 bucket, right? Looks familiar, right? And the database backup goes into my S3 bucket when I run this. And then if you see, I have a second step in this demo, right? What the second step tells me is, okay, once the database backup has been durably stored offsite in Amazon S3, notify me using a CloudWatch event. And the target of that CloudWatch event, as I showed you earlier, can be a multitude of AWS services, including automating restores or just getting notified. Like you might want to post, you might want to use Amazon's simple notification service, right? Whose target is a Slack room where your DB admins hang out and they want to know that this database backup is in S3. Okay, so that's, with that, I'm going to kick off this job right here. Say start, and let's see what happens. Hopefully it works. Okay, so now if I come to my Amazon S3 bucket, I'm going to refresh my view, if you see. Oh, there it is. This is the database backup file that is now in my S3 bucket. Now with that, I'd like to go into a next aspect. Like you might want to take this database backup and restore it now back on-prem. We can even do that, right? So if I right-click here and I go into restore a database, right? And I restore it from, and this is where I'm going to do a little cut and paste, right? So I'm going to take the file share that we talked about, right? And I'm going to put it here for restore. Say add, put a path here, paste. Okay. So you can see now the file share exported by the gateway looks like any other file share, right? That I can use and select files from. So I select this backup file, I said OK. Select it, hit OK. And I'm just going to call it from cloud restore, right? OK. Okay, database has been restored successfully, and I have a database that's been restored from a backup file stored in S3. So with that, what did we see here? What did we learn here? We took data from an on-prem application, which is SQL Server in this case, and you could use it with other backup utilities as well, the same methodology. We took that data, stored it in S3, right? And then we also took the data stored in S3, brought it back down for use by your on-prem application in the same case. In a nutshell, right, so File Gateway gives you this file-based interface to store and access your objects in S3 from your applications. And hope this demo was helpful today. Thank you.
Thanks, Smitha. Again, so you've seen how File Gateway lets you take an application that is totally cloud unaware. It thinks it's reading and writing files, stores your data in S3, and/or brings it back. And again, as Smitha pointed out, you can use some of the native S3 capabilities, such as Lifecycle. We can use some of our other services like SNS, CloudWatch Events, in order to automate downstream workloads. Really neat. Let's look now at some of the other gateway types quickly that we talked about a little earlier. Cast your mind back. We'll look at volume and tape gateway, which again, similarly provide you the ability to have storage in the cloud, accessed from your on-premises applications, natively usable in AWS. So we'll first look at volume gateway. So similar to file gateway, volume gateway deploys as a VM. Your applications mount iSCSI targets, so block-based network protocol. The VM talks to our back-end services using HTTPS and stores data in S3. Now in this instance, what we're storing is a block device. So rather than putting it in your S3 bucket where you'd see a bunch of opaque objects that you really can't do anything with, we store it in a service-owned and service-managed bucket for you. You get charged S3 rates for that storage. Because you don't have direct access to it, we can make it even more opaque and play some little games. So we do compression and some other data reduction techniques to store that data in S3 at the lowest cost for you. If you want to access those on-premises volumes in the cloud, we allow you to create EBS snapshots, which you can then use in EBS or back on the gateway. So EBS snapshots become the transportable format between on-premises and in the cloud for volumes, a point-in-time backup of your volume. Volume gateway comes in two types, and they're subtly different. Stored volumes, which was the first introduction, the first feature that we launched with Storage Gateway, aren't cached, or you can think of them as 100% of the volume being cached. So these are really useful where you have an application that has a broad working set. The entire volume needs to be available with low latency to your application. So I need all of the data on site, but I want that durable backup in the cloud. I want that point-in-time backup through snapshots in the cloud. The other interesting use case for this is where you're migrating to the cloud. So you have existing block devices today, and you want to bootstrap them, you want to get them into the cloud. So how do I do that? If you put those block devices behind a gateway, the gateway will expose them through iSCSI. The data that's on them becomes part of your iSCSI target. Meanwhile, the gateway will bootstrap that volume into the cloud. We'll copy the blocks on that volume into the cloud asynchronously while your application is still interacting with that volume. So it becomes a really nice way with a very small maintenance window to take a volume that your application is reading and writing to, put it behind a gateway, retarget your application to the gateway, and it can continue working with that same data that it was directly attached to now over iSCSI. Meanwhile, the gateway is going to take care of moving that data securely into the cloud and being able to give you the ability to take snapshots of it. Cache mode is very similar to file gateway, where we're keeping a subset of your data on premises. The interesting thing here is that the storage on premises can be much, much smaller than the actual amount of storage available to your applications. So you can thin provision that gateway down to about 150 gigabytes of local storage, with potentially 1 petabyte of block-based storage sat behind that 150 gigabytes of on-premises storage. We allow you to have up to 32 terabyte LUNs per gateway, for example. In this instance, again, we're going to keep a cache that's a sub-block level cache on the gateway, We're going to efficiently move that data into and out of the cloud transparently for your application. If he goes to read a block that's not in the cache, we'll fetch it and then serve it up to him. If the data's in the cache, it'll come straight out of the cache for that lower latency, that faster access. In all cases, your data is always really stored in the cloud. That's the durable copy. And if you need to access it in cloud, you can take EBS snaps of it, or you can bring it back to the gateway as another block device. Here's just that, EBS snapshots, this point-in-time backup. You can create these at any frequency. We have a way of scheduling them within the service. So if you want to take one every night or every 15 minutes, you can have the service schedule that for you. We also have a native volume cloning capability, which is really useful for disaster recovery testing. So one of the challenges with disasters is you don't know when they're going to happen. So scheduling a snapshot just before a disaster is not an option. And you may not necessarily want to go back to a snapshot that's many hours old. So we allow you to take a live volume and create a clone of it as another volume. Now that's great if there's a disaster because you've lost the primary, but it also allows you to do DR testing without taking an outage on your primary. You can take a copy of that volume in real time while your application is still working on it, create a copy of it and spin up your application in your disaster recovery site, point to that data and do a fake recovery. Volume clones are available instantly as we bootstrap the data over. So again, a really nice way of doing DR failover. We talked about using the gateway and snapshots and clones, so here's sort of a pictorial of that. You can take a volume that you've created through the gateway and restore it back to your primary data center maybe. Maybe you're trying to go back to an older point in time on a volume because you need to recover a file from it. So you can take a snapshot, create a new volume, pull the file off it, and then dispose of the volume, the copy of the volume that you have. You can take a snap, create an EBS volume, and attach that directly to an EC2 instance. Again, we talked a little about disaster recovery, where you can take either a snap or a clone of a volume and launch them as a new volume on a second gateway in a second data center, which may or may not be inside an AWS region, in order to provide you a disaster recovery or a second site. One of our customers that's using Volume Gateway extensively, they adopted the service in just after launch in 2012, is StemCell, a Canadian biotech firm. They use Volume Gateway to provide storage both to their main headquarters and to some of their branch offices. They centrally manage all of that. They take snapshots on a periodic basis to give them point-in-time backups and recovery points. Interestingly, StemCell, when they want to do a recovery, they actually do a recovery in cloud to pull data off. Say they want to pull a file or a data set off, they actually use the capability of being able to transport volumes from storage gateway into EBS, and then they build temporary infrastructure. Dave mentioned infrastructure as code. They have this all automated, so it spins up infrastructure in cloud, creates the gateway, creates the EBS volume from the snapshot, attaches it to an EC2 instance, pulls the data off, and then tears all that down. We switch tack to tape gateway. I talked about that a little earlier. Tape gateway is very much like the cached or the file gateway. But tape gateway is integrated with your backup app. So in this instance, we're integrated with all the leading backup vendors shown here. Your backup admin lives within his backup app. He doesn't really need to know he's using an AWS service, and that's what's really nice about Tape Gateway. It becomes a really interesting first step into the cloud. You create your gateway, you point your backup application to what it thinks of as a tape library, and you back up in the same way you would with any other physical tape library. Very similar to the demo that Smitha gave, where your application is really unaware that it's storing data off in the cloud. The nice thing here, as well as the integration that we've made with some of these vendors, is that when you export a tape from the library, so the logical equivalent of taking that tape out of the library and handing it to your offsite backup vendor, we map that to moving the data down to Glacier for long-term archival storage at that lower price point. You can pull tapes back from your archive, just as you can pull them back from your offsite vendor. Instead of taking days, you get them back in 3 to 5 hours, a standard Glacier retrieval. Then you can do restores from that. So we see lots of customers that keep long, long archives, 7 or 50 years in some of the cases of some regulated industries, of data off in Glacier. And then they keep their nearline backups, maybe their last 3 to 6 months in the library, immediately accessible to their application. Then they have that VM on-prem, which contains the cache of their last nightly backup. So they can do near-term restores directly from the local infrastructure. A lot of customers adopt tape because the TCO, the analysis here is, it's just cheaper. Much as tape infrastructure is out there, you have a lot of maintenance costs. have to keep validating your tapes. You have to do fixity, is the industry term. You have to manage and maintain the library. You pay licensing costs for all this stuff. It's expensive, and it takes a lot of staff and a lot of time for you to do that. Moving to Tape Gateway reduces all of that. Very predictable costs. You pay for what you store. It's sort of the schematic. The important point here is that the gateway is providing you access to storage in the cloud. Even though we think of it as a virtual tape library, the tapes aren't actually stored on the gateway. Again, it's a sub-tape level cache of data, really just held there to give you that low latency access, but really all of your data lives in either S3 or Glacier if you've rejected that tape. The gateway is providing you a whole bunch of device emulation, such that your upstream application can talk to it thinking it's talking to a real physical tape library. Really interesting drop-in replacement. We see a lot of customers take a tape gateway, they stand it up, they have a tape robot already, they maybe do dual writing initially. They write both to their physical library and they write to the virtual tape library. And then they realize that it just works the same as their physical library, so why are they maintaining that physical library? So they drop their physical library, and now they're backing up to the cloud with, again, that local cache for near-term restores, data in S3 for sort of their main corpus of backups, and then a longer-term archive off in S3. We'll wrap it up here. We've told you a little about Storage Gateway. Dave's told you his journey to the cloud. Thank you very much. Smitha gave you a demo of our latest feature, which is SMB on File Gateway, and using that to allow SQL Server to back up to the cloud. Hopefully this has been informative for you. Please fill in your surveys. We'll take Q&A, and we'll be off stage if anybody doesn't want to do Q&A on the mic afterwards.
Yep. Also, I'd like a quick round of applause for Dave and the direct supply team for sharing their learnings here. And I have the mic if anybody has questions, as well as stickers for anybody bold enough to speak up and ask. Questions?
With the offer of stickers, everybody starts to ask.
So when we're dealing with backups, a lot of times we're dealing with server admins, guys who have no cloud experience whatsoever. They seem to be a lot more comfortable with map drives, a G drive, an H drive, that kind of thing. In the example, Smitha had, she was using an IP address to map the drive. Can we just map it to a G drive?
Yeah, in Smitha's example, she was using a UNC path, but you can just map the drive as well. Yeah, so again, the gateway, when we're using SMB, will just appear like any other map drive or any typical UNC path.
Thanks. I have a question on the file gateway. Can I integrate that with any kind of data classification tool? So that way, I would not want files with PII data to reside in S3. I would rather keep them on-prem. Can I dissect that way and only move the data I want to put in S3?
So it's a super interesting question. Not today. The gateway is going to move all of your data into S3. In order to solve your problem, what we've done with some customers is we think of having a holding bucket. And so the gateway puts data into a holding bucket, and then you use Lambda or some downstream in-cloud process to process that data, introspect into it, figure out what it is, and only move over the data into another bucket, which is sort of your main bucket. So you sort of quarantine it, if you like, into a first bucket, and then move it over into a second bucket. But certainly one of the things that you're asking for is something we've talked about doing, is providing some element of local compute, if you like, within the gateway, or a pluggable architecture where you could put maybe virus scanning or something else in there. If you look at what we do on Snowball, for example, we have Greengrass running on the Snowball device. So you can run these lighter weight processes on your data prior to the data coming into the cloud. And we're seeing an increasing need for that around data classification and some of those other techniques. So it's something we're looking at. I wouldn't say it's necessarily on our roadmap. We're still exploring it, but you know, happy to, Dylan's there, he can give you a card. Let's talk about what your needs are there. But it's certainly not off in left field. We've heard that one from customers.
And Paul, is Storage Gateway a HIPAA eligible service?
Oh yeah, good question. Yeah, so we are on the HIPAA eligible list, and we also achieved PCI DSS 2 or 3 weeks ago. So yeah.
If I have file gateways in multiple edge locations, can I point them to a single S3 instance and maintain data integrity?
Yeah, so we highly recommend against having dual writer, but you can certainly have a single writer and multiple readers. So we do allow you to export a file share read-only. And we have a number of customers using File Gateway as a mechanism of sort of sharing content between sites, maybe east and west, or one customer that's doing it between LA and Sydney. So they stockpile all of their data in a single bucket, and each office has write access to their bucket, and the other offices have read access to it. Again, as anybody who's sort of familiar with S3, S3 has eventual consistency on the objects that live there. Multiple writers to a bucket, it's not even last writer wins. The gateway upstream for file clients will present a fully consistent POSIX file system, but we can't change S3 characteristics. So in that mode, we recommend to customers having a single writer and multiple readers if you need to sort of share across locations. And there's good reasons to do that because that cache provides the local applications sort of locality of data, especially if you're talking about Sydney and LA, for example. We are looking at multi-writer, and again, I'd like to delve into sort of some more details of what's useful for you there. If you need it today, as I mentioned it in a session earlier today, there's a number of partner offerings that we have that provide that sort of global, fully consistent file system, and they're equally good options for you.
All right. So I've noticed that they had Active Directory and Guest for SMB access. Is there ever a plan to introduce Open Directory?
So we do have AD and Guest. We haven't talked about Open Directory as something on our roadmap, but it's certainly something we can add and start to prioritize.
Do you guys have any issues with putting the gateway in front or behind DFS or DFSR, anything like that?
A volume or file?
Either or.
The SMB share on file won't work in that mode. We don't support the bits of SMB that you need for that. We have a number of customers who use volume gateway behind Windows in DFSDR setups. Again, if Dylan can hand his card out, we have a webinar and we have a couple of YouTube videos that sort of talk about that as a solution on the file gateway side. Provides a really compelling option for moving your Windows storage into the cloud.
More questions?
Is there a way to create the cache automatically with a schedule?
Create the cache?
Clear the schedule. Clear the cache with a schedule. I'm having a problem with it myself. For some data, if I delete it in the bucket, it does not really clear my cache when I browse the web page. It's still coming up on my website, unless I manually cleared it in the on my portal.
So let's talk about. It sounds like you've played with the service and you're seeing something unexpected. Is that?
Really, it is an object that I placed it. I uploaded into my S3 bucket, and if I delete the object from my bucket manually, and if I browse the website again, the object still come up from my page. So
okay.
The only way for me to clear it, that I had to go onto my portal and just manually clear my cache.
Yeah, so that instance, we showed an example of adding an object to an S3 bucket and then telling the gateway to discover that new object. If you delete an object from the S3 bucket, similarly, if you call that refresh cache API, he'll discover that the object has been deleted and he'll take it out of the file system.
Okay.
Again, one of the reasons that we provide that cache is we don't want to keep going out to S3 for every file system operation. So we're aggressively caching data so that we can minimize the amount of S3 requests and minimize the amount of traffic. And so refresh cache becomes a way of explicitly telling the gateway, I've made changes in S3 that you need to reflect in your cache. And again, you can sort of automate that either scheduled or you could use S3 event notification to kick the gateway periodic. There's a bunch of ways of automating that round trip rather than necessarily calling it through our API or our console.
That was you.
Are there plans to have a bare metal storage gateway so that I don't have to maintain any infrastructure for a VM?
It's something that we've talked about, providing other packagings. We package as a VM today. I'd love to understand specifically what bare metal platform you're going on. Obviously, that gets us into the world of supporting various drivers and various qualifications of hardware platforms. We have looked at other packagings, though, potentially even natively on Windows or containerized. or bare metal RPMs as well is something we've talked about. Wouldn't say we have plans necessarily, but I'd love to talk to you about the specifics of what bare metal platform you'd like us to be able to support, so we can start to sort of narrow in on what drivers, what hardware we need to really support. Again, it becomes a qualification exercise for us at that point.
More questions? One more? Any more?
The question is on bandwidth throttling. So the gateway, by default, will use as much bandwidth as you allow it to. We do allow you to configure a throttle, both on reads and writes. The gateway will stay within that in terms of how much data we'll send. You can configure that through API, so we see a number of customers that say back off the gateway during business hours because they have users using the same connection, and then make it unlimited overnight when potentially your backups are running. So why constrain it if nobody else is going to be impacted? So we do have built-in bandwidth throttles that the VM will respect that you can configure through our APIs or through our console. I'm getting the hook, so I'm happy to take questions off mic if anybody wants. But thank you for coming, and please submit feedback. I hope it was useful to you, and hope the rest of your day is productive.